Hello, everyone, and welcome back. Before we begin here today, please like and subscribe because it really does help out our channel. So today we'll be talking about algebra, and we'll be talking about intro algebra. And we're going to be solving the four equations shown on the screen here. And we're going to solve each of these equations for the unknown x variable in 1, 2, and 3, and the unknown n variable in number 4. And then finally, we are going to check all our answers by plugging our answer back into the equation to make sure that it makes sense. So these are single variable problems, and we're going to be looking at each one simultaneously or by itself here. So starting with number 1. So we have x plus 3 is equal to 17. So what we're looking for here is the x variable. We need to determine what x has to be in order to add 3 to it to make it 17 total. So with these algebra problems, no matter what the variable is, x, y, z, or in this case, number 4, n, you treat everything exactly the same. So what we're going to do here is that we are going to move this 3, and we're going to take it to the other side of the equation because we want to get the variable by itself such that we would have something that says x is equal to, and that's the value we're looking for. So what we're going to do is that we are going to subtract 3 from each side of the equation here. So we're going to have x remains exactly the same, and then we're going to have plus 3 minus 3 is equal to 17 minus 3. So what this essentially does is that it will remove the 3 from the left-hand side and takes it to the right-hand side with the opposite sign that it had. So essentially, we have plus 3. To get it over to the other side, we have to subtract 3 from each side, which leaves us with minus 3. So we end up with x equals 17 minus 3, which gives us 14. So let's double check our answer here to make sure that this 14 is correct. So what we're going to do is we're going to plug back in the 14 for x up here because that's what x equals. So we're going to have 14 plus 3 does indeed equal 17. So we know that x equaling 14 is the correct answer for number 1. All right, so moving on to number 2, we have x plus 5 equals a minus 12. Same idea and same principle as before. We want to get the x isolated by itself on one side of the equation. Now, it doesn't matter if it's on the left side or on the right side, as long as we have the variable by itself so that it will state x equals something. So just like with before with removing the 3, we're going to take this 5 and we're going to move it to the other side of the equation. So we're going to take this 5 and we want to move it to this side of the equation. So what we can do is we can subtract 5 from each side because we have positive 5 here. Subtracting 5 from that would give us 0 on this left-hand side, leaving x all by itself. So if we subtract 5 from each side, and the reason why we do it on each side is simply because whatever we do on the left-hand side, we have to do the exact same on the right-hand side to keep the equation within the same ratio and values here, the same symmetry that we would have on each side. So we would have x plus 5 as the original, minus 5 from the left-hand side, and then we have minus 12 minus 5 from the right-hand side. So these two 5s will cancel, plus and minus, they equal 0. And then we would have x is equal to minus 12 minus 5. And minus 12 minus 5, excuse me, minus 12 minus 5 gives us minus 17. So let's double check this before we say that's our final answer. So we're going to take this minus 17 and we're going to plug it back in to our original equation up here. So we have minus 17 plus 5 is equal to, indeed, a minus 12. So since our equation comes out to be exactly what it was before with the minus 12 as the answer, minus 12 here, we know that our answer of x equaling minus 17 is the correct one. All right, so moving on to the third one. So we have 5 is equal to x minus 7. So just like what I said before, it does not matter if the x is on the left side or on the right side. Typically, having x on the left side of the equal sign is the better nomenclature, but it does not matter. You would solve the equation exactly the same way as before, where you want x to be isolated by itself, either on the right side or on the left side. So trying to get x by itself, what we're going to do is we are going to add 7 this time because we have minus 7 here, and we want that to cancel, move that 7 to the other side of the equation. So we would add 7 to each side here. So we would have 5 plus 7 is equal to x minus 7, and then plus 7. And just like before, the side with the variable of x will cancel out and be 0. So we are left with 5 plus 7 is equal to x. Therefore, x is equal to 5 plus 7, which is 12. Which you could also write it like this if you wanted to. It means the same thing. So what we're going to do is we're going to plug in 12 up here and for x and see if we can get 5. So we have 5 is equal to 12 minus 7. And indeed, that equation, that statement is correct, so that we do know x is equal to 12. One more to go. And that is number 4. And this one is n minus 6 is equal to 12. So just as I said before, it does not matter what the variable is. If it's x, n, y, z, it does not matter. It's still a variable. You treat it exactly the same. It's an unknown that you have to find. So just like the previous 3, what we're going to do is this, since this is minus 6, we want this to cancel out on the left-hand side with the variable here. So we have to add 6 on each side. So we end up with n minus 6 plus 6 is equal to 12 plus 6. So with n minus 6 is equal to 12, and then adding 6 to each side, this side will cancel out. And then this side over here is 12 plus 6, which gives us 18. So plugging back in the 18 and for the n up here, just to double check to make sure that we do get 12, we have 18 minus 6 does in fact give us 12. So we do know that the variable n must be 18 in order for this statement to be true. So it may seem a little time consuming to actually plug in the variables into such simple equations. And even with the first one, you may be able to see it and be like, well, that has to be 14, adding 3 to it equals 17. These are just elementary equations and steps to get you in the process of thinking this way, because in the future, these equations can be quite long and they can have multiple variables in them. But it doesn't matter how long or how difficult the algebraic equation looks like with one single variable in it, you solve them exactly the same way. The same method of making sure that you isolate that unknown variable on one side of the equation. So another way that this can be done, if you start getting really good at it, what you can do, and we'll have more videos like this with this method. But essentially what you want to do is that, looking at the first one here, with x plus 3 equals 17. Since the sign is positive here, you can just move this 3 to the other side with the opposite sign. So you would end up with the 14 again. Instead of taking the time and actually writing in minus 3 on both sides, you can just take it to the opposite side with the opposite sign. That's the key phrase there, opposite side with the opposite sign. So for instance, looking at the third one, where we had 5 is equal to x minus 7, we want to isolate the variable x. So what we're going to do is we're going to take this minus 7, take it to the other side with the opposite sign. So that would be 5 plus 7, because plus is the opposite of minus, is equal to x, which would give us 12. So that's more of a faster method, but starting out with algebra and getting the hang of it, showing the minuses on each side or the pluses on each side is very, very helpful to get you in the mindset of thinking that way. So I hope this video was helpful for you. And if you want to see more problems solved of this variety, please check out other videos on our channel. Thank you for watching, and I hope you have a great day.